Good morning, and thank you very much for attending this presentation on live partition mobility. I'm Jackie Lynch, and I'm a National Solutions Architect for Forsythe. I will be recording this session so that I can put it up on the internet. That way you can review it later if you choose to. So I do have everybody on mute. If you do have any questions, please feel free to type them in the chat that I have open. So again, thank you very much for sitting in on our Forsythe Talks session on live partition mobility. This morning what we'll be covering questions about why live partition mobility, and we'll actually look at some of the things behind live partition mobility, how it works. Depending on time, we'll actually do a short demo. And then if we do have time at the end, I'll also give you a quick update on the most recent PowerAid announcements. So let's start with why we even bother with live partition mobility. There's a number of things that you can use it for. The one that a lot of people use it for is workload consolidation, workload balancing. And the reason for that is I can have a workload running on one server, and as long as I have the resources on another server, I can move that workload to the other server without taking an outage. It's been used in many different ways, from companies who at night they will actually move workloads off servers when those servers aren't so busy so that they can actually power off those servers to save power. Clearly the biggest use for it is this planned kick outages, where you know that you've got to do a firmware update that requires powering off the whole server. If you plan for it properly, you can actually move all the LPARs off live, do the server maintenance, and then move the LPARs back. So that can actually save you from outages, even planned outages. And of course, when you're ready to migrate to new technology, for instance from Power 6 to Power 7 or Power 7 to Power 8, you can use LPM to move those workloads. There's also a term called inactive partition migration. This moves a powered off partition. This is a partition that you have shut down correctly. We're not talking about crashed kernels. You cannot migrate failed machines or failed kernels. So the key point on this is that it is not a replacement for HACMP or any other high availability or DR solution. This is about moving a workload that is currently working to another server. The one thing that you will see is at the very, very end of the migration, there is a suspend that takes place. It's actually typically less than a second. That's when it copies the last few pages of memory across. When it does that, new connections during that time won't be able to connect, but you won't lose connectivity on any current connections that you have. So that's one thing to keep in mind. So as I said, LPM provides the ability to move an AIX or Linux partition, and actually an I partition in certain cases, from one LPM server to another compatible server. What do we mean by compatibility? What we mean is that there are requirements for the management console. There are requirements for the power system, for the VIOS server, and for the actual LPAR that's being moved. On top of that, there are some storage requirements that need to be taken care of. So LPM is managed through one of four ways. It's either managed through a hardware management console, through IVM, which is basically an HMC type application running in a VIO server. SDMC, which we no longer do, which was supposed to be the replacement for the HMC, and the FSM, which is Flex System Manager for the Flex servers. Actually, now the HMC can basically manage the Flex Power servers, the Blade servers, and the rack servers. So typically where we see LPM, there's nearly always an HMC involved. I'm going to go through some quick definitions because you'll hear people use these terms. Active partition mobility, that's when you have a running LPAR and you move it from one physical machine to another with everything continuing to run. Inactive partition mobility is where you take a machine that has been shut down, an LPAR, that has been shut down, and you move it. And the difference between the two primarily is that active partition mobility, the amount of time that it takes is dependent on the amount of memory and how active that LPAR is. The more active the LPAR is, the more memory that's being changed, the longer it will take, because the copies require time. Inactive partition mobility is very, very fast because the LPAR is actually shut down, so we're really just copying all the definitions. So typically inactive partition mobility could take less than 30 seconds. Suspended partition mobility, if the server supports suspend resume, you can actually suspend a partition, then move it across, and then resume it on the other server. And the reason that you might do that is simply because it's going to be faster because the memory won't be changing during the suspend. Partition mobility and partition migration both refer to the same feature. So these are some of the definitions that are helpful to know. So there are migration phases that we go through, and there's a difference between active and inactive. So in an active environment, we have to validate the configuration, create the new LPAR, create the new virtual resources. We then migrate the state of the LPAR in memory. And that's the thing that I said, it takes the time, and it's impacted by the amount of memory you have and how active that memory is. So a 512 gig LPAR that's very busy is going to take a lot longer to move than a 32 gig LPAR that is doing nothing. We then remove the old LPAR configuration and we free up the old resources. So basically the LPAR and all its definitions disappear off the old server. For inactive migration, we go through all the same steps except we don't have this migration of the state because the LPAR is shut down. So it's important to note the difference between these two. So we're going to start out by making sure that you understand the importance of staying current. LPM originally came out 5 of VIOS. The current version is 2.2.3, and in fact I believe it's 2.2.3.4 just came out, so this is one behind. Each one of these VIO server versions brings out different features and changes things. As an example, with 2.2.3, there are some changes that impact the SEA that could be of value to you. So it's important, if you look at when these end of marketing and end of service dates are, it's very important that you get to be current. And my recommendation to everybody is to get to 2.2.3. 2.2.2 at a minimum, but 2.2.3. And 2.2.3 is effectively AIX61 TL9 Service Pack 3. So it's very current. Service Pack 4 just came out. So with LPM, this is not something that you wake up one morning and decide, you know, I think we'll do live partition mobility. With LPM, planning is absolutely critical. There's a bunch of links I have in here where you can go and check things. But some of the things to note are minimum HMC levels, minimum firmware levels, Power 6 hardware. Actually, nowadays you need to be at 5.3 TL12, otherwise you don't have 5.3 support. So, and some minimum VIOS and AIX levels. Just keep in mind, these are absolutely minimums. You really want to be higher than that. With the HMC, once you get to version 7.3.4, that brings in remote migration. Today, you probably should be at 7.7.8 or 9, and if you're going Power 8, you need to be at version 8. Just remember that version 8 does not support Power 5. So, but with HMC version 7.3.4, that's when you've got the ability to move a partition between two systems that are managed by different HMCs. We call this remote migration. You also had the ability to use LPM between a HMC managed system and a Flex managed system, and that came in at 7.7.1 of the HMC. Other requirements are that everything has to be virtual, so you need to be using virtual Ethernet, you need to be using virtual SAN, whether it's vSCSI or NPIV. And at the time of the move, the LPAR can't have any dedicated resources. It can use dedicated resources normally, but you need to de-LPAR those out or remove them somehow before you try to do an LPM move. And there's a prereq site here that has a bunch of different prereqs listed. So you need two servers. Obviously you can't move a partition from one server to another if you don't have two servers. Those servers need to be Power 6 or higher. You can move an LPAR from Power 6 to Power 8. You can move it from Power 8 to Power 6, but there's some things you have to do first. So you need to have PowerVM Enterprise Edition. That's required for LPM, and it has to be on all of the servers. You can't have one server that's running Enterprise and one that's running Standard and move between them. LPM comes with Enterprise Edition. All of the LPARs have to be on the same network with RMC established, and they have to be under the control of a VIO server. The HMCs have to be able to talk to each other. The IO server levels have to be compatible. I talked about the storage being virtualized. So storage has to be zoned to both the source and the target. If the target system can't see the storage, then your LPM move is either going to fail, or worse, it may work, but as soon as you try to issue a command that requires it go to disk to get it, it's going to fail. Also, with vSCSI, you can actually do vSCSI a couple of ways. You can take a whole disk that the VIO server owns and assign it to an LPAR, or you can carve up logical volumes on that disk and assign them to an LPAR. LPM does not allow you to do LVM-based disks. They have to be, with vSCSI, they have to be where you give it the whole disk. Disks have to be on a SAN and with no reserve. There's a whole section in the LPM Red Book, although a lot of the information on LPM has now moved into the PowerVM Red Books, and I have the links to those at the end. The other thing that I have down in, well, actually a couple of things at the end here. The target server, if it has an LPAR running on it that has the same name as the LPAR you want to migrate, it won't work. So it's very important that you have naming standards where you never end up with duplicate LPAR names. And the target system has to have available resources. So as an example, if you have a 4-core 32 gig LPAR that you want to move, you have to have 4 cores and 32 gig available at the target. If you don't have that much available at the target, then you need to use the LPAR to make the source LPAR smaller before you try to move it. And a comment to that is this is where people quite often make a mistake, where they architect their systems thinking that they're going to use LPM between them, but they don't architect additional resource for LPM to take advantage of. So just be very aware of that if you want to use LPM, you have to have enough free resources on a server somewhere to LPM it to. There's a number of checks that you have to go through, making sure that the actual LPAR is HMC compatible, making sure that your VIO server is set up as a mover service partition. And I'll show you some things in a little bit where you can actually see how you check these. You have to make sure that the asynchronous stuff is set up correctly, which the HMC does automatically. And as I said, deallocating dedicated I/O adapters. Also, if you have a CD that you need to unattach it from an LPAR, this also applies if you use a fixed file-backed optical. You need to actually disconnect the VT op device from that LPAR before you do a move. Otherwise, it will fail. The VIO servers have to have synchronized time of day clocks. A good solution for that is to use NTP, the Network Time Protocol. And when they talk about applications and operating systems being migration aware or migration enabled, they need to actually be able to deal with the fact that something like the serial number and the underlying architecture changes, which the minimum levels that we've got quoted actually can handle that. Oracle 10G, etc. support LPM. There are some things that around LPM that we need to talk about if you want to use it for Oracle, and it has to do with some licensing issues. A whole separate conversation, but just be aware of that. Also, the memory region or LMB size has to be the same on both servers, and I'll show you how to check that. That's something you should check whenever you bring in a new server, because it requires a power off and power on of the server to change it. And if you're using things like active memory sharing, suspend, resume, or trusted boot, if the mobile partition is configured for them, then there are actions you have to take at the target before you can do a migration. Lots of things to think about. Now, I was in Hungary a couple of weeks ago, and Linda Flanders gave a really good LPM presentation there. So there's a couple of slides I've put in here with some points that she made, most of which I was covering anyway, but obviously check in the processor architecture, make sure that the servers are authorized to PowerVM, making sure that the firmware is at the right level. I mentioned the LMB and the target system having enough memory and CPU. Also, another thing to keep in mind, and this is particularly when you're moving from Power 6 or Power 7 to Power 7 Plus or Power 8, it's fine when you're going that way, but if you're going back, if you have an LPAR that's set up to use 0.05 of a core, then you need to check that the server that you're moving it to supports 0.05 of a core. For instance, Power 6 supports a minimum of 0.1 of a core, so you can't move an LPAR there that wants to use 0.05. So it's just one other thing to keep an eye on. It's more important when you're going backwards than when you're going forwards. And again, checking for the AMS, etc. This is some of how you actually do those checks. So here, if we go into our HMC, we bring up the actual server properties, we go into capabilities, and we're looking for active partition mobility capable, inactive partition mobility capable, and then the other one is IBM I partition capable. So those are the kind of things that we're looking at. And I'm just seeing if I can bring that up for one of my servers so I can show you. This would be properties for my server. And if I go into capabilities, here you can see I scroll down, active partition mobility capable, inactive, and IBM I partition mobility capable, plus a whole bunch of other stuff. Then we can actually go into processors, and we can have it, and we can actually look at migration and see, so how many migrations can I support? So if I do that here, you can actually see that for inactive partition mobility, I can support 4 migrations at a time. For active, I can support 8, and right now I have none in process. So that's some of the things that you can check. You can also use the lssysconfig command or the lsmigrate LPAR command on the actual HMC. So here, because I'm going to do a migration between my 750 and my 740, I check both of them. And then in terms of checking the LMB size, again, what we're doing is we'll click on memory, and here you can see it actually calls it the memory region size. But I would check this on both servers. Here it's 256 meg. So, and I have active memory sharing support. So very, very easy things to check. And just remember, if you have to change this, you have to use the ASMI, and you have to power the server off and on, which is disruptive. And again, I checked it on both servers. Then you actually want to check that you've got the MSPs set up. So what you would do there is you would go into the VIOS server LPAR, and you would look at the properties for that. And what you're really looking for is this little MSP box checked. I happen to have it checked on both VIO servers on both servers, and that way I can just pick which one I want to use. So typically I use my secondary because my primary is carrying most of my SEA workload. So here I've checked it on both servers. Then in terms of the HMC, we want to make sure that we're at the right versions of the HMC software. If you're doing remote HMC operation, there's some things you have to do for that are very specific. Namely, making sure RMC is working between them, but you also have to configure SSH key authentication. Most people use LPM within their data center, and then they use like a high availability solution beyond. But just be aware that you do have the ability to do it, and it's very well written up in the Red Book. You have to have working RMC daemons, and I've got some slides later on how to check for that. And obviously network access, if you can't get to the partitions, the IO server, the mobile LPAR, and the HMCs on the network, then you're not going to be doing any live partition mobility. So for remote migration, these are some of the requirements for it. Obviously 2 HMCs, 1 local, 1 remote, version 734 of the HMC software, network access, SSH key authentication, and that's actually not just between HMCs, it's the VIO servers and the LPARs as well. And then all the normal prerequisites. For the VIO servers at both ends need to have SEAs. And part of validation is that it will check all the virtual switch settings, etc. We have to have the same external fiber channel storage, whether it's vSCSI or NPIV, or you can do this with virtual SCSI using iSCSI. None of the VIOS adapters can be marked as required, so whenever you're setting up LPARs, you should always mark their adapters as desired, and they should also be specific to that client. You can't mark them as any client. Additionally, when you set up the destination or target VIO server, you need to make sure it has spare virtual adapters. So if you know you need 20 virtual adapters normally, don't set the maximum virtual adapters to 20. Set them to something larger. So, just seeing if I have that here. Here we go. So if you look at this, I don't have very many virtual adapters in here, just a few, but my maximum set to 80, and I'm currently using 24. So if I want to do an LPM to here, I have plenty of virtual adapters free, because remember, one of the things that it's going to do is it's going to set up all those virtual adapters at the time of the move that it needs for the LPAR that it's moving. So I have to have some free. Obviously, one VIO server per server has to be configured as a mover service partition, because that's what's going to do the negotiating. And if you are doing AMS, active memory sharing, the destination has to have a spare AMS paging device that it can use for this AMS setup. For the actual partition that's being moved, there's a whole bunch of things to check, and you'll check these in the actual configuration. Obviously, the operating system level, whether you've got RMC daemons. The things that I have asterisks by, the huge memory pages, etc., you cannot use active migration for LPARs with these. However, you can do an inactive migration. So if you have these and you're using them, which I've never seen them used, but if you are, then you will have to use inactive migration. So these are all some of the things that you need to check. Also, any LPAR that's being migrated cannot be configured as the service partition for the server. And normally I turn that off anyway, but just be aware that it cannot be the service partition. And we have to check the processor compatibility modes and so on, which we'll talk about in a little bit. You're also going to look for things like active memory expansion. If you have LPARs that are using active memory expansion, then whatever server that you're moving it to better support active memory expansion. And there are some things around using suspend resume. Remember, I said that one of the mobility options was a suspend and a resume. Both servers have to support suspend resume, and the target has to have a storage pool that is big enough to support the mobile partition. With respect to IBMI, the destination has to support IBMI mobile partitions and the restricted I/O mode. There's a lot of detail about that in the red books, but those are the couple of things just to watch for. Also with NPIV, one of the things that you'll find is that there are actually two worldwide names. And those worldwide names, we have to map both of them. So if I go to my LPAR here, here's my virtual fiber. If you have a look here, you'll see there are two worldwide port names. When the LPAR's up, this one that ends 10 will light up. The one that ends 11 never lights up. But both of those have to be zoned at both locations, the source and the target, because it's actually the 11 that it uses for the LPM. So just be aware that you need to, once you've defined the virtual fiber for the NPIV, ensure that they don't just zone the 10, because that's the one they're going to see, but they also zone the 11 here. And it'll be a different number for different LPARs, but they need to be zoned at both ends. And I already said that everything needs to be virtualized just before the migration. Remember I talked about that MSP checkbox? That's actually used, the MSP is only used for active migrations. So what the MSP is actually going to be doing is actually moving that memory. So the memory state is going to include the partition's memory itself, the hardware page table, which keeps track of what pages are in use, etc., the processor state, the virtual adapter states, what they're actually doing, any NVRAM, the time of day partition configuration, all of that is part of what gets moved to the remote location. And basically the MSPs talk to each other to get that taken care of. There are also these things called VASI devices, and they set up a communication path between the VIO server and the hypervisor. So if we go back, you could see here there's a communication going on here and here, as well as this MSP to MSP. So the MSPs use the VASI to gain access to the partition state. So basically the MSP is going to talk to the hypervisor, get the mobile partition state, and then it will pass that over to the other MSP. If you want to find out information about the VASIs, you can do an LSDev on them. And there's also a VASI stat command that actually lets you monitor what a VASI is actually doing during a migration. Now, LPM is heavily dependent on RMC, which basically is used to manage resources within a system. So it lets the management console talk with partitions to do things like shutdown, dynamic LPAR, all those kind of things that happen when we click on some of the icons in the hardware management console. So it turns out that LPM uses RMC for its migrations, and it actually operates over the network between the management consoles and the LPARs and so on. So we need to make sure that RMC is actually functioning. So, and it's got to be functioning between all the things listed here. One way to quickly check if it is actually working is to actually do operations and then pretend that you're going to do a shutdown. So if I was going to do that, what I'm really looking for, and I'm just going to bring my HMC over here, is when I go to do operations, is shutdown grayed down, grayed out? Are any of these grayed out? If they're not grayed out, then my RMC is working. So clearly it's working, which is good. If you do have to shut down and bring up RMC, it can take 5 or 6 minutes for it to re-establish all its connections. So if you've just rebooted an LPAR, you've got to give it 5 or 6 minutes to really re-establish its RMC before you test. On an LPAR, you can use RMC control to stop and start RMC subsystems, and there's also a recfgct command if you need to reinitialize RMC. As a last resort, if you're having a problem with RMC and rebooting the LPAR hasn't fixed it, you can reboot the HMC or FSM. So in terms of configuring the external storage, and I've already touched on this, we can use vSCSI or NPIV, which means you can use shared storage pools as long as the source and destination servers are part of the same VIO server storage group. So if you're using shared storage pools, as long as both of them can see the same storage pools and are part of that group, then you can use LPM with LPARs that are using shared storage pools. As I said, for virtual SCSI, they have to be external SAN-based physical volumes, and they can be accessed via fiber channel or iSCSI. We don't really care. The most important thing is that we zone the same LUNs to both VIO servers. So with vSCSI, the zoning is done to the VIO server, to the WWNs, which are the actual, if you do an LS-ATA on the FCS, it's that network ID that shows up on there. We disable SCSI reservations before we create any virtual targets. If you don't disable SCSI reservations before creating the virtual targets, and I'm talking about when you actually map that HDisk to that LPAR, then you will have problems. And then for the virtual fiber channel, which is NPIV, we actually zone those virtual worldwide port numbers that I showed you before. And remember that we have to zone both of those. So just looking at disk access just real quick, if we look at a virtual SCSI model, basically the external storage is defined and the VIO server actually handles it. So it sees all of the HDisks, and you then take those HDisks and you assign them to clients as general SCSI disks. So the fiber adapters show up in the VIO server. They don't show up because what we have in the client is what looks like a SCSI environment. MPIO drivers on the client are just generic AIX MPIO. MPIO drivers in the VIO server need to be the correct host attach kit for the disk subsystem that you're running. And for NPIV, it's really more of a pass-through. So you have the fiber adapters defined at the VIOS. You also have fiber adapters at the client, and so you need to tune them in both places. The HDisks only show up at the client, and therefore you need to run the host attached kit with the correct device drivers at the client. And then, of course, the zoning is done all the way through to the client, which is why you're doing those virtual fiber adapters, including the secondary one, versus here, the zoning is done to the VIOS. So LUN masking and zoning is very different for vSCSI versus NPIV. And that's really what we're talking about here, and I showed you this before, where with the NPIV environment, we have two WWPNs instead of the single one that we would have for vSCSI. In terms of the virtual networking, that destination VIO server has got to have an SCA defined that supports the source LPAR subnet and VLAN. So if you're using a different subnet and VLAN on the normal SCA on that VIO server, you need to add a second one that will support where the source is coming from. Also make a note of the fact that we've now brought out SRIOV adapters, and the SRIOV adapter is treated kind of like the IVE or HEA. It is a physical device and it is not compatible with LPM. So if you want to use LPM, do not put those LPARs on the SRIOV, IVE, or HEA. Now, having said that, as of TL5 of 6.1, you can use an HEA port, and we're talking Power 6 here, but it has to be part of an Ether channel configuration, and basically you fail it over to the virtual Ethernet adapter prior to doing the the migration. Okay, I had mentioned processor compatibility mode, and a couple of pieces of terminology. A partition has a preferred mode, and that is the mode that when it comes up, it will try to come up in that mode. And then it has a current mode, which is whatever it's currently using. So as an example, an LPAR running on a Power 6 has default Power 6 or Power 6 Enhanced, which is really Power 6 Plus, as options for preferred mode. If you have a look here, you've got the refreshed Power 6 server, which is really the Power 6 Plus. These are the modes it offers, and so on and so on. So I can set my Power 8 LPARs up to have a preferred mode of Power 7, so that whenever they would boot in Power 7 mode versus Power 8 mode. What does that really mean? What it means is that I can then migrate them to a Power 7. If they're running on a Power 8 and Power 8 mode, I cannot migrate that LPAR to a Power 7 because the Power 7 does not support Power 8 mode. I have no problem taking an LPAR running on a Power 7 and Power 7 mode and migrating it to a Power 8. When it comes across, it will run in Power 7 mode, which basically means SMT4. In order to change it to Power 8 mode, I would need to shut it down and bring it back up, and so on. So just be aware that there are these preferred modes, and I can't go back I cannot do an LPM if I'm running in Power 8 mode to something that is running at something less than Power 8 mode. I have to change that LPAR first to be a mode that is supported on that receiving server. And you notice at the bottom there's no Power 7 Plus mode because Power 7 and Power 7 Plus use the same instruction set. Power 6 and Power 6 Plus did not use the same instruction set. And you can basically check the compatibility mode by looking at the LPAR properties, and you're going to look at under hardware processors. So here we go. We'll go to hardware, and under processors down here you see my processor compatibility mode is Power 7, which this is a 750B model, so I would expect that. And then you can also, if you want to know what the actual options are, you can look at the sharing mode, and I forget where that is actually, and you have the option of processor compatibility. I think it's still on the processors. Let's have a look here. If you are running dual VIO servers, the mobile partition is going to expect the same configuration on the destination server. So it's a little challenging to take something supported by a dual VIOS and migrate it. And in fact, it will cause you problems because if you're using NPIO, where you have two VIO servers feeding paths in, it has to be dual VIO server at the remote end, or you have to remove all the paths to one of the VIO servers, and there's an override option you can use during migration. But you've got to remove all the paths first. So if you only have one VIO server on the destination, then you're going to have to remove the paths on the source, check these two boxes, and then do your migration. But just remember, when you come back, you're going to have to, after the migration, add back in the paths, etc. So just something to watch out for. That's why it's a good thing to have a standard that, I do dual VIOs everywhere, but it's good to have a standard where you take care of that. So I had mentioned inactive migrations, and there are some differences in configuration for your inactive migrations. So they're a little bit more flexible in some things you can do, and one of the reasons for that is that the LPAR is shut down. So for instance, you can use huge memory pages, you can use barrier synchronization registers. If there's physical I/O configured in the profile, it doesn't matter. When it does the migration, it will just remove that physical I/O from the definition at the remote end. So when it builds that definition at the remote end, it will not include any of the physical I/O. Now, if you're dependent on that physical I/O, that's a problem. So be aware of it. You still have to support the preferred processor compatibility mode, and you still have to have whatever the minimum OS versions are for inactive migrations. And they may not be as high as they are for active, but don't count on it. So when you actually migrate an LPAR that is shut down, it looks at the last activated partition profile or the last running configuration, and it will use those. So if you've never actually activated the LPAR, you can't migrate it. The way around that is to boot the LPAR into SMS mode and then shut it down. Then you can activate it because it has technically a last running configuration or a last activated profile. So you can script migrations. You can use the MIGR LPAR command, and if you run it with a --help or use the man command, you can get the syntax. It gets updated all the time as they add features, so I would check it before you run it. And you can be really specific when you use that command. You can select the source and destination MSP servers. You can select how you map out the virtual SCSIs and virtual fiber channels and so on, and a number of other details. So this will allow you to set up a script to run on your HMC where if you have regular things that you do migrations for. So for instance, if there's 4 or 5 LPARs you always migrate off before you take certain actions, you could have that in a script. So we're going to cover some of the steps for LPM now, and one of the first things that it has to do is it has to do a validation. So pretty much what the validation does is it checks for compatibility and capabilities. It checks for RMC, makes sure the LPAR is actually capable. It checks for the resources at the remote end. It makes sure it can map virtual adapters and checks a few other things. And then it gives you a response about whether or not it can do the migration. So this is a lot more detail in exactly what it does during this validation phase. I'm not going to go through this in great detail, but basically it's going to check for physical adapters. It's going to check that you're not using logical volumes for your vSCSI. It's going to check the partition state, etc., and it will check that you're not going to have conflicts. It will also make sure, for instance, if you support 4 active migrations, if you're already running 4 active migrations, it's going to tell you that it can't do it. So that's what the validation does. So this is your validation screen there, and actually I'm going to bring up the real one here. So basically, it's telling me that it's going to move to the destination system if I've only got one to choose from. So I'm going to click these two, and I'm going to do a validate. Now, when the validate comes back, eventually, it's actually going to allow me to pair up the MSPs if I want to. And it will also give me a list of any known problems and so on. So here I'm actually going to change my MSP pairing just because I can. So I'm going to have it go from VIO2 to VIO2, because those are my secondary. So it's basically telling me here that there's some differences in the numbers. At this point, I've done my validation. I can do my migrate, but I'll hold off on that for a little while. But you can see the things that the validation does. And you also see that it was very quick. All right, so this is just showing you what I just looked at. Now, you may also get errors or warning messages. So the warnings here are basically saying that it's going to create a new profile. It's telling me that it can't maintain the slot numbers and so on. I didn't get those messages when I did it just before for you because when I ran it, I actually told it to override them. Then you basically kick off the migration. So you just click on migrate and off we go. And one of the things I usually do is I bring up an nmon, and in that nmon I run, I monitor the serial number because it's amusing to watch it change. So let me just log in very quickly. What I did is I jumped into nmon and I ran the R command, and what it does is it shows me the serial number I'm running on here. It gives me a whole bunch of other information. So I'm running on 69348, and you can see that my LPAR number is 15. That's one thing that may change when we do the migration, is that LPAR number may change. We'll watch that. So I'll just push these away and we'll talk a little bit more and go through. So remember I mentioned the suspend that might happen? That typically happens when this gets to about 99%. When the migration gets to 99%, that's typically around then is when it does that little suspend, which runs for less than a second. And this is just showing you the nmon output down here. All right, when the migration gets to 100% and is complete, you'll notice, so here you'll see the serial numbers, the 348. You'll notice that it changes to 34C here. And also, the LPAR definitions disappear from the HMC. So here on my HMC, you can see that NL2 is migrating and running, and it has this 2005 code, and that will stay that way until the migration is complete. On my 740, it has actually set up the definition for NL2 here, which was not there before, and that migration is ongoing. When it's complete, NL2 will disappear from the 750, and these are all things we can look at. So the migration steps, basically it creates the shell partition on the destination system, which we saw. It configures the destination and source MSPs. Now we selected 750 VIO2 and VIO2 on the 740. Then going to connect to the hypervisor through that VASI and set up a private full duplex channel to transfer the partition state data. So the MSPs actually have a private channel between them. It then uses RMC to say to the mobile partition, hey, go migrate yourself. And we create all the virtual target devices, virtual SCSI devices at the destination. You do not do this manually. The hypervisor must do it talking to the HMC. And then the MSP starts sending the partition state data. So that's what's going on right now. We're sitting at 34% and stuff's moving. And if I'm busy on that LPAR doing things, like I said before, it will take a little longer. Okay, we keep copying memory until we've got almost no modified pages. Once we've got all the pages over there with none modified, that's when we do that little suspend. During that suspend, we copy the last few modified pages and state data, which is typically pieces of the kernel. And we then continue running on the destination server. We recover any I.O. because if during that 1 second or less there was an I.O. that happened, we have to recover that, and we retry any uncompleted I.O.s and let the VLAN adapters know that we're back. So when you see the 100%, you have to wait till it actually comes up and says that it's complete. Just because it says 100% doesn't mean it's complete. Once it's complete, that's when we go back to the source and we free up any resources that are there. So the cores and the memory that were being held, so in this case, it was holding on my 750, it was holding 4 cores and 32 gig for that LPAR. Basically, that LPAR gets shut down because it's not being used anymore. All the definitions get deleted and the resources get released. and now somebody else could use them technically. We close the network channel, we close the VASI channels, we remove all the definitions for the vSCSI and VFC adapters, the MSPs get told that the migration is complete, we delete the profiles, and we're basically done. And then at the target server, you can add any resources that you want to add to the LPAR that's just moved over there. So what are the effects of the migration? Obviously, there may be some affinity characteristics for the LMBs that could change because you know if you're going from Power 7 to Power 8, for instance, or whatever. Maximum number of physical processors, etc., could change because you're moving to a different box. Your level 1, level 2 cache sizes and associations. Pretty much, if you're moving from architecture to architecture, then you may see anything that's architecturally different is going to be a change for the server properties. At the time of the migration, if anybody's using a console, they'll be disconnected. So this is not something that you can monitor through the serial console. You can monitor it through an SSH connection, and you know, as you can see, right now I'm at 86% of my migration, and my SSH connection is still running quite happily, thank you. Once the migration is complete, you can open a console session again. And I already talked about that temporary network outage. It says seconds, but it really is. I've never seen it even be a second. It's very, very fast. I already talked about the fact that the adapters, their definitions will be removed when everything's over with. One thing that also may change, as I said, is the session ID number. In my case, it happens that 15 is not being used on the other LPAR, on the other server, so you'll notice that my NL2 came across as LPAR ID 15, and it happens to be LPAR ID 15 at the source. If it was 14, which is in use on the 740, then that LPAR would migrate with a different ID. So I had mentioned to you that when it gets to 100%, it doesn't mean it's done. Right now it says 100% migration complete, but notice how I still have the stop option. Until this close lights up, this migration is not complete. But you can now see that the serial number has changed. So we used to end with an 8, we now end with a C. So the LPAR is over there. And the close has just come up, which means that it's complete, so I can close it. And interestingly enough, just as that close came up, the LPAR disappeared from here. You notice there's no longer a number 15. If I go to the 740, it's now a running LPAR, not a migrating LPAR. So it's completely over on the other server now. Okay. So we're going to talk about a little bit about what's new in some of the VIOS server versions, because I had said you really want to get to 2.2.2 at least. So specific to LPM, what came in at 2.2.2 was some big performance improvements. And they had to do with the fact that previous versions of the code were single-threaded when they were doing the memory copies. Now they can do some of it in parallel, and they've done a lot to improve that performance. There's also some new firmware level that's required to support, there's a new firmware level support matrix, and the number of concurrent migrations has increased. And there's a new pseudo device that we'll talk about, and you can actually specify VIOS server fiber channel port names and so on. So for concurrent migrations, we can now support up to 16 of them. It is firmware specific. I think my server was limited to 8, but it depends on whether it's active or inactive. But depending on the box that you're running and the firmware level that you're running, you should be able to run potentially 16 concurrent LPMs. However, don't be misled. You can't run concurrent LPMs to multiple boxes. All of the LPMs must be going from the same source to the same destination. So I can move 16 LPARs at a time from server A to server B, but I can't move 8 to server A and 8 to server B. So just be aware of that. Now I can move them between them. If you only have gigabit adapters to your MSPs, you're restricted to 4. And if you want to get above 8, you have to have more than a pair of VIO servers. So what that really is speaking to is if you want to do 16 at a time, then you're going to have typically 4 VIO servers. So just a couple of things to predict concurrent migrations. The pseudo device that I mentioned is called VIO LPM 0, and it basically is used to control live partition mobility migrations. There's a couple of commands that you can use, an lsdev and a chdev. I'll show you the output of those in a second. You also have the ability to specify the fiber channel ports using this VIOS fiber channel port name. So I've got a bunch of material on this page that you can look at to see this, and you can use that using a migrate LPAR if you want. In terms of the pseudo device that we mentioned, these are some of the things you can change. The number of active migrations configured, the concurrent migration performance level, and so on. If you look at the commands, like I do an iOS level on my system, I see 2233, and then I can do this lsdev command. This is the device that we were talking about, the VIOS LPM 0. So these are what the defaults are set to. So right now my configured concurrent LPMs are 8 for this MSP. Which is not surprising because I only have 1 pair of VIO servers. And then there's some concurrency and a number of other parameters. I would not recommend that you go changing these without understanding what you're changing. Then with 223, there are a few things that were brought in. This came out pretty much towards the end of last year. So this is where shared server pools 4 came out, where you could do mirrored pools, pool shrinking, some scaling, and so on. There was a number of more LPM performance improvements, some vSCSI redundancy improvements. They also made changes to the VIO Server Performance Advisor so that you get more information for fiber channels, SCAs, and shared storage pools. And if you're running PowerVM Enterprise Edition, which you have to for LPM, you now get the PowerVP Virtualization Performance Monitor for free. It's actually included. But probably of more interest is that there's now a single command that allows you to evacuate a server. So if you need to move a whole server, all the LPARs on it, there is a single command to do that. One other change was the changes to the SCA. So today when we define an SCA, we also define a control channel that has its own VLAN. So typically we define 3 virtual adapters, and we have our SCA goes on one, our I usually create a separate virtual adapter that I put the IP on, and then I have my control channel. And here's my make vdev command. Well, with 223, and you have to be at least HMC 7.8, you now have the ability to have multiple SCA share VLAN 4095 within the same virtual switch, and you don't have a control channel. Basically, if you define the SCA without a control channel, it will use VLAN 4095 for the control channel. It's reserved as of 778 and higher for internal management traffic. Now you can't do this if 4095 is already in use somewhere else, and you certainly don't do this. You certainly don't go out and define 4095 on any switch or anything like that. There's a whole bunch of information in Chapter 4 on the Red Book, but it's another option for you when you're setting up SCAs. So I mentioned that server migration evacuation command. When you're at these levels, you can migrate, I say all the partitions. You're going to have a big Ethernet pipe, lots of CPU, etc. This is what the command would look like. And it says here you can't hit any of the maximums. I have a feeling that means that if you have 100 LPARs and your maximum 16, you're not going to be able to do the all. But it's definitely an option for some of those smaller servers. For HMC 778, that's what this is talking about here, this -all flag. You can also stop the migration happening as well. And by the way, when you stop a migration, everything fails back. All right, now HMC version 8, which has some interesting things, and I wanted to talk about HMC 7.8 because I think it's important that there's some things you understand. First of all, you have to be on version 8 to run a Power 8. So if you want to move to Power 8, you will have to run HMC version 8. It requires at least a CR5 or CO8 HMC. It will not run on the earlier HMCs. They don't have enough CPU or memory. Additionally, if you're thinking of going If you're going to HMC version 8 and you only have 4 gig of memory in your LPAR, in your HMC, sorry, you may want to consider adding some additional memory to your HMC. One of the things that HMC version 8 does is it validates entitlement for Power 8. Power 8 now actually requires entitlement for firmware updates. So it's set up automatically for you when you get the system, but just be aware that entitlement is now something that it actually does manage. So there's also a new performance and capacity monitoring task. So you can actually set the system up and tell it to do some monitoring. There's a whole bunch of LPM improvements for vSCSI, SRO, VISA support, and a number of other things. But the most important thing is that if you're running anything prior to Power 6, it can't be connected to this HMC. Additionally, Power VC and Power VP, I mentioned these. You get Power VP, which is the graphical performance monitor, with Power VM Enterprise Edition. So since you have Enterprise Edition to run LPM, you may as well consider taking advantage of that. And then these are some of the references that I have for you. These two here are a couple of tips. They're actually LPM preparation setup lists. There's also the Power VM Enhancements Red Book that actually goes through all the new things that came out with Power VM and what has a lot of details on LPM. And there's an Introduction and Configuration and a Managing and Monitoring Red Book. You should always make sure you have the most updated ones of these because they're very, very useful. So I wanted to mention those as references. So that's everything I have for you on LPM. As you can see, it was actually pretty simple migration. It didn't take very long, but again, I had 4 cores, 32 gig of memory, and I wasn't doing anything on the LPAR. Obviously, as you do more on the LPAR, it takes longer. So, but hopefully you found this to be useful.